Hello, today I am going to explain ARM architecture. Here ARM is nothing but Advanced RISC Machine. My name is Suresh Bojja, Department of ECE. To watch more videos, please subscribe to my channel OpenBox Education. So before going to the architecture of ARM, let us we see what is Van Neumann architecture and Harvard architecture. In the Van Neumann architecture, the program memory and data memory will be the same. And in Harvard architecture, the program memory and the data memory are separate. This is the main difference between these two architectures. Now we will see that the ARM architecture. In this ARM architecture, we have arithmetic logic unit is there, and here we have A bus, and here we have B bus. Before this B bus, we have a barrel shifter is there, and here we have multiply register is there, and here we have a register bank and program counter, incrementer, and the address registers. And here from this address register we have 32 address lines will be there, that is from 0 to 31. And here data out register and data in register, here we have the data lines are from 0 to 31, that is nothing but 32 data lines. And here we have another unit is there, that is the instruction decode and control unit. So let us we see that the ARM architecture clearly. So first one is, it is the Van Neumann architecture. So in the Van Neumann architecture, here we have the program memory and the data memory will be the same. So this architecture is simply called as a load store architecture. Here is load is nothing but this instruction copies the data from the memory to registers in the processor core. So here when you are using that load, the name of the load is nothing but it copies, that is this instruction copies the data from memory to registers in the processor core. And store is nothing but this instruction copies the data from registers in the processor core to memory. That is, this is from data from registers to memory, and here load nothing but here data from memory to registers. Simply we can call this one as a load and store architecture. So in ARM processors, the data can be manipulated only in the registers, not in the data memory. So the data can be manipulated in only the registers, not in the memory. And next we will say about the data bus. The data enters into the core ARM through the data bus. That is, we know that already the data will be entered into the ARM core through these data lines, or nothing but data bus. The data may be in the instruction, maybe opcode or a data item. That is, within a instruction the data may be a opcode or a data item. Here the data and the instructions share the same bus because it is a Van Neumann architecture. That is why the program memory and the code memory will be the same, so that the data and the instructions share the same bus. And next one is that instruction decoder. This unit decodes the instruction opcode, read from the memory, and then the instruction is executed. That is nothing but decode unit. Unit will decode the instructions which are read from the memory, and after that it executes that instruction. So this is about that instruction decoder. And next one is the register file. So this is the bank of 32-bit registers used for storing data items. That is the purpose of this register file. And next one is that sign extend hardware. So the ARM core is a 32-bit processor. The instructions treat the registers as holding a signed or unsigned 32-bit values. That is, once again I am repeating this one. The instructions treat the registers as holding signed or unsigned 32-bit values. When processor reads 8-bit or 16-bit numbers from memory, the sign extend hardware converts these numbers into 32-bit values and then places into a register file. That is, this 16-bit and 8-bit numbers will be converted into 32-bit number by using this assign extend hardware. So here the ARM core is a 32-bit processor. The instructions treat the registers as holding signed or unsigned 32-bit values, and this sign extend hardware converts that 8-bit or 16-bit numbers into 32-bit values and then places into a register file. Next one is that arithmetic logic unit and multiply accumulator unit. Simply we can call it as a ALU and MAC. The most of the ARM instructions are the two operand instructions. The two source registers, here we have RN and RM. These are the two source registers are there in ARM using the internal data buses A and B. That is, these two internal registers, source registers, will use that internal data bus of this ARM. The internal data bus of this ARM is nothing but here bus A and bus B, and the source registers are here RN and RM. The ALU or MAC reads the operand values from these registers, that is RN and RM, via A and B buses, so that this ALU or MAC perform the operation and store the results in the destination register, that is RD. From this, then it to the register file. So this is a functioning of this arithmetic and logic unit or the multiply and accumulate unit. So here we will use two source registers RN and RM. So we will get the data to these registers from A and B buses. After doing this arithmetic and logic unit or multiply and some division operations, here after that it stores the results in destination register RD and then to the register file. And next one is the address register. This holds the address generated by the load and store instructions and places it on the address bus. And next one is the barrel shifter. The address of the RM register alternatively can be pre-processed in the barrel shifter before applying as an input to the ALU. That is, the contents of the RM register will be pre-processed by this barrel shifter before applying as an input to the arithmetic logic unit. And next one is that incrementer. For load and store instructions, the incrementer updates the contents of the address register before the processor core reads or writes the next register value from R to the memory location. So here incrementer will do that for load and store instructions. The incrementer updates the contents of the address register before the processor core reads or writes the next register value from R to the memory location. This is about that functioning of this incrementer. And next one, the ERM data types we have. So here generally a byte is nothing but 8 bits, and here the half word, generally a word is called a 16-bit, but in ARM data types a half word is nothing but a 16-bit, and here word is nothing but 32-bit. This is the ARM data types. Thank you very much for watching this video. To watch more videos, please subscribe to my channel. In our next classes, I am going to discuss about ARM thumb programming model.